Hi everyone, before we get started on encoding, we're going to add just a little bit to your introduction to memory notes where we're going to look at the two main models of how your memory works. So you'll want to pull those out first and then we're going to move on to encoding. So what you'll see here is a model of how our memory works overall. This gives you a nice overview. We talked about before that it's 3 steps. So the 3 main steps are encoding here, storage, and finally retrieval. And we'll be looking at each of these processes separately. But I wanted you to see just the overview so you kind of know where we're headed. So we start off with encoding. This is the process of actually getting that information that you're trying to remember into your memory. So if we look at our pictures down here, this would be kind of like you inputting the information on your keyboard. You're actually typing the information in. The next step here is storage, and this is actually retaining that information over a period of time. And we'll talk about how there's both short-term and long-term memory. So here, if we use our same computer analogy, we have a disk here, a little bit outdated, but if you think your flash drive or something like that, that would be our storage. And then last, once it's in storage, the last process here is retrieval, and that's once it's in storage, we have to be able to get it back out. So this is our actual computer screen as if we were viewing it for a second time. So there's going to be 2 models, processing models of how your memory actually works. So the first one is the Atkinson-Shiffrin 3-stage processing model of memory. And we're going to go through these step by step. So first here, see if I can get my mouse going. First here is a lot of the information that you see around you. Our brains know that we don't need to remember every single thing that we see all the time. So a lot of it is just fleeting, what we call sensory memory. Think of the information your brain is taking in using your senses. And it's there just for a couple seconds, not even that long, oftentimes, and that information is gone. But if there's something that, for various reasons, and we'll talk about them, where our brain knows we need to hold on to this information for a little bit longer. Maybe something strikes us as important. That information is going to be encoded one of 2 ways. One way is through automatic processing, and the other is going to be through effortful processing. And we're going to code this through rehearsal. We'll talk about what that means. What we do know about our short-term memory is that it only holds just a few items at a time. We'll talk about this analogy of the magical number 7 plus or minus 2, and we'll do some activities involving that. And then third, once it moves through short-term memory, the last step here is moving it into long-term memory, and those memories would stay there until we need to retrieve them later. There sometimes are some misconceptions that our long-term memory can only hold a limited amount of information, but research has found that that's really not true, that what goes into our long-term memory is pretty permanent and limitless. It's not like you only get so many gigabytes of memory. You can have limitless amounts of memory. So this is the 3-stage processing model. And what we'll see next is very similar to Atkinson-Shiffrin, but it's a little bit updated. So we'll look at the differences. So first here, if you're following the chart at the top, you have external events. This is what you're seeing in the world around you. So like this scene here. Let's say you're at some sort of sporting event, a football game. And as you're looking around you, you see all of these people here hanging out. This is all sensory memory, and our brain's deciding, most of this stuff here I don't need to remember. But what we do, so that's here, sensory memory. But let's say there's something that catches our eye, something that seems important, like this guy here. He looks kind of angry. Maybe he might cause some sort of trouble, so we're going to pay more attention to him. So this information is going to be moved from sensory memory. It's going to be encoded into first our short-term memory, also known as our working memory. Then what's going to happen is if we stare at this face long enough, we rehearse it in some manner, or if it seems important to us, it seems like this person might be dangerous to us, then not only will that face go in our short-term memory, it's going to be encoded into our long-term memory. And it will be saved there until, let's say, someone asks us later on about the man we saw in the crowd, we'll be able to recall some of the details about him. Then what will happen is, when I want to recall that later on, let me go back here, sorry about that. What will happen later on is that will be then retrieved. We'll talk about how that happens. The main difference that you'll see here between the other model and this model is you'll notice here at the top, this line where it says unconscious processing. Sometimes what we find is that memories don't necessarily have to be encoded. Sometimes we remember things even without them being encoded. That happens automatically, and we'll talk about that in just a moment. So this is the end of the intro to memory notes. I want you to take some time and answer this question here. What differences do you see between the Atkinson-Shiffrin model and the updated model? Make sure that you can describe the differences between these two models of memory. So now what we're going to look at more specifically is encoding, meaning how does that information get into our brain so that we can store it and then retrieve it later on. So there's going to be two different ways that we encode. The first is automatically, and this just means that it occurs without us really being aware it's happening and without interfering with our thinking about other things. There's different information that might get encoded automatically. Information about space, meaning where you are in your environment. Information about time, meaning think about if you've ever lost or left your cell phone in one of your classes during the day and it gets to 6th period and you realize you don't have your phone. You might be able to go back and retrace your steps throughout the day, even though as you were going throughout your day, you weren't purposely trying to remember everything that you did. Our brains encode those details for us automatically. And last, the type of information that it gets encoded automatically is frequency. So automatic processing occurs without our awareness, and the key thing here is without interfering with our thinking about other things. So this allows us to do more than one thing at a time. So you might be able to walk and chew gum at the same time. So it doesn't require a lot of thinking about other things. At first, many things that eventually become automatic don't start off that way. So when you're first learning to read or you're learning to drive, it requires your full attention and your full effort. But the more and more you practice them, these things are able to then be done automatically. What allows us to do more than one thing at one time is called parallel processing. So we can process many different aspects of a problem all at the same time. We don't have to go step by step like a computer might have to do. So take a moment, read this phrase, and what you might have read it as is spring is the most beautiful time of the year. Because you've been reading for a long time, your brain is automatically processing the language. As you look at it now, if you didn't see it the first time, you might notice here that it says spring is the most beautiful time of the year. So automatic processing is great because it allows us to read things quickly. It doesn't require us to spend a lot of time thinking about what every little word or letter means. But sometimes it might cause us to miss things like this. So we're going to move on now to effortful processing, and this is what we're going to spend the most time on. Effortful processing, this is the type of processing where if you're trying to learn new information, you're trying to remember things for your classes, this is what your brain is doing. So it's encoding that requires your attention and some sort of conscious effort. And there's going to be lots of ways that we effortfully process information. So One of the ways is just through rehearsal, and that's conscious repetition of the information. If someone tells you a phone number and you're trying to remember it and you don't have no paper, you don't have your cell phone around, you might just repeat it to yourself over and over again. That's rehearsal. What we know from research is the amount that we tend to remember depends on how much time we actually spent trying to learn it. So even after we learn it, if we rehearse it over and over again, the chances of us actually retaining that information increases. So overlearning is a good thing. So as you're studying your note cards and your new vocab, the longer you rehearse, the better off you will be. This first concept is spacing effect. And this isn't necessarily a way to help you remember directly, but it's something that you should keep in mind as you're trying to study for your classes like this one. So spacing effect probably goes against how a lot of you study. A lot of times when you guys have a test or a quiz, you'll cram the night before. You'll say, I'm going to spend half an hour or an hour and I'm going to study for my test, or I'm going to study my vocabulary words, or I'm going to study how to do this math problem. But what happens and what research shows is that we don't retain that information as well if we're just cramming it. Instead, according to the spacing effect, we should be spending that time spaced out over a longer period of time. So, for example, if you have, let's say, an hour to spend studying your vocab terms, instead of spending that hour right before the quiz or the night before the quiz, your time would be much better spent spreading out that hour or 60 minutes into 6 days of 10 minutes each leading up to the quiz. So it shows that this leads to better long-term retention than if you were just cramming right before the quiz. One way to help us remember or to encode information better is known as the self-reference effect. This means as you're studying information, instead of just trying to study it and learn it without attaching it to any other personal memory, it's not going to be encoded as well. Where instead, if as you're reading your information or studying your note cards, if you try to find personal meaning in what you're studying, you're going to be more likely to remember that later on. So if you think of your note cards or the examples that I have you write on your note cards, if you make personal examples, if you think about, oh yeah, overconfidence was when I thought I got an C on my calculus test, but really I got an F. That's self-reference effects. You're finding some sort of personal meaning to what you're studying. You're thinking about, how is this information relevant to me? And the last part here for part 1 is how we encode. This is called the serial position effect. Think about if you've ever tried to learn a list of items. Say you have to go to the grocery store for your parents and they say this list of 5 items on a list. And you get to the store and you thought you remembered them all, and you know for sure you have that first item in the list, maybe the first 1 or 2, and you're pretty sure you know those last items in the list, but that one in the middle you can't quite remember. So according to serial position effect, we tend to recall best the last and the first items in a list that we're given. And we'll do an activity in class that helps to illustrate this effect. So this is the end of part 1. You're going to move on now to part 2 to finish about how we encode.